So complex numbers, I hope you have a little bit of appreciation and motivation to tackle them. This is not a mystery. To be quite honest, if you take a plug and check approach, which I tell my students throughout my FE electrical and computer exam preparation program, which I tell my students throughout my PE Power exam preparation program, that if you think that just the calculator or just the reference handbook is going to be good enough for you on the exam, especially on the PE Power exam, you are in for a big surprise. Okay. So the approach that you should take with no matter how easy a concept is or how difficult a concept is, you should ask yourself honestly in your mind, right? Do I really understand this concept? Am I able to fundamentally answer the questions using first principles, right? And this is one of the things that students, when they're going through my programs, see me, hear me say again and again and again and again. Okay. Now, if you're like, Wasim, don't waste time on complex numbers. I am a calculator right? Wizard. I'll be able to figure things out. Well, calculator won't be able to do everything for you. And I'll show you with just two examples. Well, let's start with the forms of complex numbers. We have rectangular form, okay, which is essentially in a Cartesian coordinate, your x coordinate, x item, x entry, x component, which if you're looking at it from the standpoint of real and imaginary, is A, and the imaginary component is B. So whatever value you have for A tells you how far along the x-axis you are, and whatever value you have on B tells you how far along the y-axis you are. So again, nothing fancy, nothing scary, pretty benign so far, okay? We can actually convert the Cartesian, the rectangular form into two other forms, okay? The other one, the second one, which I'm going to show you very quickly, is polar form. And the third one, which is kind of fancy, a little bit more interesting, a little bit less commonly encountered and used, is the Euler's identity. So this particular form, rectangular form, is pretty handy when we are doing addition and subtraction, okay? And I encourage my students in my FE electrical and computer exam preparation program to use a little bit of an old school approach, at least during the learning process. Once you've understood the basic concept, go crazy with the calculator, save yourself time, cut down a 3-minute question into a 30-second question by using all the advanced features of your calculators, whether you're using TI-36 or whether you're using a Casio, okay? But do recognize at a high level why rectangular form is so handy when you're doing addition and subtraction. The fact of the matter is that you can simply collect all the real parts together, okay? Add them together. You can simply collect the imaginary parts together, add them together, and you will get the resultant. And you can do the same thing for subtraction. Now, this is not that easy when you are using polar form, okay? And division and multiplication is not that easy when you're doing rectangular form. So let's take a look at polar form. The idea is that you take the x component, which is A, you take the y component, which is B, square it, put it under square root, and you get the magnitude. So what is this magnitude R? And these formulas are given in the reference handbook. This is our R. Previously, we were looking at a value of A over here, a value of B over here. So this is AB. Now, all of a sudden, we are expressing it differently. We're talking about the same thing, right? But in a different language. And that language is now polar form. So you have R over here, which is a magnitude. And it depends on the X and Y components. The thing that becomes super interesting over here is the angle. Now, again, if you want to take a very surface level, learning attitude, all you'll do is pick up the calculator, do a tangent inverse arc10 of the y component divided by the x component. And this is the first encounter with reality where you're going to find that just knowing the calculator is not good enough. Now, my students tell me that on TI-36, there is a particular way of punching in the formula such that your second and third quadrant, we'll do one practice problem, I'll show you there, gets taken care of. But I have about 20-minute discussion in my on-demand course where I explain students why you have to be extremely careful when you're dealing with negative x and y quantities, okay? So if you think about it, we have quadrant 1, we have quadrant 2, we have quadrant 3, we have quadrant 4, okay? When a calculator sees a positive value of y divided by positive value of x, it interprets that in the first quadrant, correct? Now, what about if we are operating in quadrant number 2? So if you punch in quadrant number 2, your x value is negative, but your y value is positive. From the standpoint of the calculator, is there any difference between a negative 2 that is dividing a 3 or a negative 3 that is being divided by a 2? There's no difference. Okay. So who has to handle this? Who has to take care of this? Who has to make sure that we are actually in quadrant number 2 and whatever answer that is being calculated needs to be adjusted? Well, it's your responsibility, right? So the way that you handle it is that you drop the plus or the negative sign associated with either x or y. You recognize that you are actually operating in quadrant number 2 and you do the 180-degree adjustment to it. Okay. Now, is this expressed clearly in the reference handbook? They don't make any reference to this. But can you be tested on this? For sure. If I want to really test your understanding on calculating the phase angle when dealing with the polar form, I would throw in a practice problem like this to test your understanding, deep understanding, where actually your calculator is going to fail you. Does it make sense? And similarly, let's see what's happening when x is less than 0 and y is less than 0, which means which quadrant are we operating in? X is negative and y is negative. Which quadrant is this, guys? You have the 4, 1, 2, 3, 4 quadrants over here. Which quadrant is x and y both negative? Yes, we are in quadrant number 3. Now, when you are in quadrant number 3, what do you get? Minus y minus x, which is the same as y by x because the two negative signs cancel each other out. Does the calculator know that you're in quadrant number 3? No. So what should you do? You should drop the signs. You should do a tangent inverse of y by x and then do a 180-degree adjustment and so on and so forth. So this is the first instance. And if you think about it, when you're dealing with polar form, and that's basically essentially our RMS, okay, in the single phase systems, in three phase systems, in AC systems, correct? Now, if you tell me that, Wasim, I got the magnitude right, but my phase angle is either positive or negative, I'm not 100% sure. Do you think that from that point onwards, all the calculations you're doing for single phase systems, all the calculations you're doing for three phase systems, all the calculations that you're doing for delta-wye impedances, are they going to be accurate? Not at all, right? A phase angle plus or minus here or there in one of the early steps is definitely going to cost you point on the P power exam and obviously on the FE electrical exam as well. And remember that a question lost on the P power exam has a weightage of 1 divided by 80. Okay. All right. Whatever that number turns out to be, I think it's going to be 0.125 or something. Whereas a question lost on the FE electrical has a lighter weightage. Does it make sense? Okay. And a fundamental elementary concept like complex number and mishandling the phase angle can cost you an entire question on the P power exam if you still knew everything downstream. And what do you have downstream? You can have some fancy conversions from delta to y. You can have some fancy conversions from line quantities to phase quantities and going back to the line quantities and then to the phase quantities, depending on what the problem is asking, right? But if you made this mistake right up front, what do you think? Well, you definitely lost a point, right? And the reason was a very fundamental concept that you were not able to latch on to as early as an FE electrical. Okay, so hopefully this is a wake-up call. Now, the third thing I want to tell you is Euler's identity. It's kind of, for a lack of a better term, like an orphan child. It gets ignored in the context of complex math. And the reason is that it is sort of a hidden identity, like a formula somewhere in the FE reference handbook. Nobody really looks at it. But let me tell you this. It will make a very, very strong comeback in the PE power exam, preparation in the exam specification, okay? Under transmission line modeling when we are dealing with long transmission lines. And it takes the shape and form of sine hyperbolic and cosine hyperbolic x. I always do a very quick crash course in my P Power exam preparation program when we encounter transmission lines. It's in section number 4. And I remind my students that, listen, guys, Euler's identity, remember when we're doing FE electrical, I told you that e to the power of I theta is equal to cosine theta plus I times sine theta. So we actually have to relearn, revisit, refresh that, because when we are doing sine hyperbolic, okay, sine hyperbolic actually embeds Euler's identity. Cosine hyperbolic embeds your Euler's identity. And you cannot directly punch this into the calculator, especially when you're dealing with imaginary numbers. Okay. Now you can see a full picture view of things. And the whole point of showing you this in a stepwise manner is that please do not take shortcuts in your preparation. Whether you're preparing for the exam on your own, you're using my exam prep resources or considering my exam prep resources or any other exam prep resources, you will do yourself a huge favor by slowing down and every now and again, asking yourself, am I really getting a good handle on this? I know it's a painful process comparatively speaking, at least in the early stages when you're getting your, wrapping your head around it. But it is the way, in my opinion, for the P power exam especially, it is probably the only way to go about. Okay, for FE electrical, the reference handbook does a decent job. So even if you keep your understanding at a fundamental level, you can potentially get by. But the FE exam is also not an easy exam. Okay, so keep this in mind. So let us dive into some of the practice problems. All right, I'm going to do just a quick couple of practice problems. And you can turn around and say, Wasim, you know what? You solved this problem in 10 lines. Guess what? I did this in 30 seconds. Well, that's good. But the fact of the matter is, do you truly understand how we go about this conversion? And let me just assume for a second that I don't give you neat and clean numbers. Instead of these numbers, if I throw variables at you, will your calculator come to your rescue? I don't think so. Okay. So it's always good to know things from first principles. So when we are going from very easy problem, probably FE level problem, and most definitely not a PE power level problem, in my opinion, you're given a rectangular form and you're being asked to convert that into a polar form. Pretty simple, straightforward. You take the magnitude, you calculate the angle, and this is in the form of r theta. When you convert to Euler's form, it is always advisable to take the intermediate step, convert it into polar form, and then go into Euler's form. And then again, if you're doing it by calculator and you're given neat and tidy numbers, you can skip some of these steps altogether. What happens in the Euler's form is that this angle theta that you see over here forms a theta of this formula. Okay, you have to be extremely careful in terms of handling this theta as radians or degrees. If there is any hint of pi, okay, let's say you're starting from here. If pi shows up, okay, then you have to always, always, always treat this as radians. If there is explicitly degrees mentioned, then be my guest and use degrees in here, not a problem. But don't lose a point by interpreting this as radians in your mind and putting the calculator in a degrees form, okay, and vice versa. All right. So as far as angle is concerned, pretty simple, straightforward. You just take the angle, which happens to be pi by 4 over here, you insert it in here, and off you go. What do we do with the magnitude? When you have solved all of this, just simply take the magnitude and divide the whole thing by that. And that gives you your Euler's representation in the exponential form. And this comes in super handy. Remember, you are about to encounter sooner or later cosine hyperbolic x and sine hyperbolic x, which requires you to go back in time and revisit and refresh Euler's identity. Okay. Any questions on this? Pretty simple, straightforward, right? Now, this can also take a little bit of a graphing form where I give you a complex number. You see this pretty easy. You can plug and check your way through the calculator. And I ask you to convert this into polar form. Not an issue. But here's the catch. What if this was not a 3 plus j4, but it was a 3 minus j4? How do things change? If you put this on Cartesian coordinate, right? Let's say this is 3 and this is 4. You're looking at something that is resulting in a line that has this type of slope or presence, okay? But if I look at 3 minus j4, so 3 is positive, but j is negative, then you're looking at 3 minus j4 over here. Is there any adjustment that is required? Potentially. Well, because when you calculate it, remember, is when you're punching minus y by x, for it minus y by x and minus y by minus x is the same thing. Similarly, when you are over here, you have both minus and minus, they're showing up as positive, right? The calculator is going to treat it as a positive number for which the angle is being calculated, and it's going to give you this angle. So you have to make all of these adjustments with pi, depending on which quadrant, sorry, you are operating in. So this is how things look on the inside. Okay, this is the FE Electrical and Computer Exam Preparation Program. My email is wasim@studyforfe.com. Wasim, my first name, at studyforfe.com. I think you would have received all the meeting invitations from there as well. So I personally onboard every single student who enrolls in the program, whether FE Electrical or PE Power, whether you're using just the on-demand course or the on-demand plus live training. So a stepwise onboarding sequence over here. I go over how the course is all organized. And then in step number 2, I give you an overview of how the community is organized. And the community is basically integrated with the course. So let me show you this. Whenever you're working through the course content, this small icon is appearing over there. And you can see this is FE Electrical and Computer Exam Preparation Community Sections, Mathematics, Probability. If you have a question in math, for example, you can post it over here and expect a response within 6 hours to 12 hours by myself or my teaching assistant. So this is, and same approach for PE Power, as you can see over here. Pretty active community, and you're not going to get questions necessarily answered by some random students, although I encourage students to participate, but eventually the final word is going to be either mine or my teaching assistant. So you look at mathematics, you have multiple line items in math. So you have straight line equation, you go through straight line equation lecture, a downloadable PDF is made available to you whenever you basically click on any lecture. This can serve as good reference as notes for yourself. And then you go through the lectures over here, and then the quizzes. All the quizzes have detailed solutions. And on the left panel, if you look at this, and complex number, for example, what we did, we have a 13-minute lecture, first of all, and then we have additional practice problems, which is another 26 minutes, calculator tips for complex numbers, right? And then an entire quiz for complex numbers. Okay, matrices, same story. So what you see on the left-hand side, and at each lecture obviously has detailed explanations. What you see on the left-hand side are multi-part lecture series for every single deep topic. And this is all mathematics. So even if you've been out of school for a long time, you can very easily catch up on this and refresh your knowledge in detail. Then you have probability, then you have ethics, and you have econ, and so on and so forth. Let me show you computer sections. These are one of the more challenging ones that students find, and they're intimidated by them. When you look at computer systems, for example, right, these are all the lectures and the quizzes that you have in computer systems. In software, you have all these lectures and quizzes with detailed solutions and everything. And computer networks, which is one of the most lightly weighted topic on the exam, check this out. Some of my students have told me that the content that is in computer networks is almost like CCNA level in terms of the depth. Okay. Then we have PE Power. Oh, one thing I forgot to mention. At the end, you have full-length computer simulation practice exam. And then we have PE Power, same approach, but recognizing that this is a different exam, more difficult in some ways, slightly easier in other ways. Approach also changes. Instrument transformers, if you guys remember, I mentioned right up front, it's not even mentioned in the reference handbook. And I go through a multi-part lecture series on instrument transformers over here, correct? With multi-part quizzes And the idea is to really understand and deeply appreciate these concepts so that even if you're asked questions in a tangential manner, you can cope with them. Codes and standards tends to be one of the biggest worries on the exam for a lot of students, especially if you don't have a solid background. And you can see we start with codes and standards over here, downloadable spreadsheet. Then we have a multi-part lecture series on NEC with multiple quizzes, deep dives, explanations that will get you ready for NEC essentially. Okay. Um, so this is just section number 1 of PE power. Then we have section number 2 where three-phase systems, as I told you, are super important. They impact everything else. We have multi-part lecture series on three-phase systems, and that basically gives you an idea of how important three-phase systems are for the rest of the content. And I mean, it just keeps on going in terms of, and it's, don't get me wrong, the idea is not to overwhelm you, although while you're preparing for the exam, those of you who are already preparing for the exam, it is almost impossible not to get overwhelmed by the exam preparation.